Hi guys, welcome to the Pepcoding. In this video, we are going to solve max chunks to make array sorted. So what question says is, we have given an array having one possible permutation from ranging 0 to array.length minus 1. And we need to split that array into some number of chunks. This means we need to partition them, and if we individually sort them, we will get a sorted array. There is one important point, that is, we do not allow to shuffle the chunks. We cannot shuffle the chunks for getting the sorted result, sorted array. So let's see. And we need to return the maximum chunk to make array sort. Now, let's say we have this array. Here we can see the elements are ranging from 0 to length minus 1. Now, if we want the maximum chunks, we can partition them individually from here, 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 and here. We will get 0, 1, 2, 3, 0, 1, 2, 1, 0, 2, 4, 3, 5. 1, 0, 2, 4, 3, 5. But if we sort them individually, we cannot get the sorted answer. This means if we sort them, we will get 1, 0, 2, 4, 3, 5, which is not sorted. So we can't partition them individually. Now, if it wants the minimum chunk, this means we can partition them from 0 to 5. If we sort them, we can get the sorted array. This means the minimum chunk is 1. But in this question, we need the maximum chunk. So for doing this question, we are going to use chaining technique. So we have array having element 1, 0, 2, 4, 3, and 5. Indexes are 0, 1, 2, 3, 4, and 5. Now if we see the range of this element in this array, it can go from this to it is equal to the 1, and in the next element it is greater than 0. This means it can go till 0. Now for next element it is smaller. This means the range of 1 is from 0 to 1. Now if we see the range of 0, we can get the range as 0 having range at that position only. Now for 2 have the range till that position only, because the next element is greater. Now we are at 4 having range from that position to 4 is greater than 3. It can go here also from 4 to 3. Now the element 3 having range till that position only. Now we are at 5. The 5 having range till that position only. So here we can see the element 1 and 0 having range till index 1. The element 2 having range till index 2. Element 4 and 3 having range till index 4. And 5 having range till index 5. So this means if we sort them, if we partition them in this form, this will be our first chunk, this will be second chunk, this will be third, and this will be fourth. That means the maximum chunk is 4. If we sort them, we can get 0, 1. Here this will be 2. In this it will be 3 and 4, and here it will be 5. So we can get the sorted array. So for partitioning them, we need to check the range of all the elements, because all the elements having the indexes from 0 to array.length minus 1. We have the element from 0 to array.length minus 1. Let's take another example. Let's say we have 3, 0, 1, 5, and 4. So this having 0, this is 1, this is 2, this is 3, this is 4. I have missed something. I have missed 2. So 0, 1, 2, 5 and 4. This will be 3, then 4, then 5. So we have elements from 0 to 5. Now let's see the range. Here the range of 3 is from this point to 3 is greater than 0. It can go 3 is greater than 1 also. 3 is greater than 2 also. 3 is smaller than 5. And here we can see the range of 3 is from 3 to index 3, from 0 to index 3. Now we are at 0. The range of 0 is till that position only. Now we are at 1. 0, the position of 1 is till that position. We are at 2. The range is till that position. Now we are at 5. At 5, 5 can go to 4 also. So the range is from 5 is till 4. That is from index 4 to 5. And the range of 4 is till that index. Now if we sort them, here we can see all the elements till 3 having range in between 0 to 3. 3 having range from 0 to 3, 0 having range from 1 till 1, 1 having range from 2 to 2, 2 having range from 3 to 3, and 5 and 4 having range from 4 to 5 and 5 to 5. So this means we have chunk A and chunk B. That means the maximum chunk are 2. Again take example. This time I am going to take example like this: 3 0 1 2 5 4 8 7 and 6, having index 0 1 2 3 4 5 6 7 and 8. Now here I'm going to take a maximum to check the maximum element, that is maximum index. I'm going to take a count for finding the number of chunks. Now at the first element the maximum is 3. At the second element the maximum is 3. At the third maximum is 3. At the fourth maximum is 3. If we compare them till this element, we have the maximum as 3. Now we are at 5. The maximum is 5. But here when we are at 3 and we are at the index 3, we do know that the range from 0 to 3 and 0 having the range till 0 because our max is not changed. 1 having range till 2, 0 having range till 1, 2 having range till 3. Our max is not changed. This means we can increase the number of count of chunks from here. From 0 this will be 1. Now max is 5. Next element is smaller, max is 5. Now next element is greater, max is changed. But here we can see at this point we have the second chunk, so number of count will increase by 1. Now we are at 8. Next element is 7, it is greater. Next element is 6, it is maximum. And for next there is no element left. This means this is the third chunk. So we are increasing the number of count from 2 then 3. Now when we are increasing the number of counts, here we can see when the maximum here 3 is equal to the index, that is 3, we are increasing the number of count. Here when maximum was 5 and index was 5, we increase the count. When the maximum was 8 and index was 8, we increase the maximum, we increase the max chunk by 1. So this means we have a condition when we need to increase the count, when we need to partition our array. We need to partition into chunks. This means when maximum is equal to the index, we need to increase the count. This will give us the max chunk this is the condition. We only need this condition, and we will traverse from this array. We will have a maximum, we will have a count. Maximum will start from the first index. So let's write the code. Now we need a maximum. Maximum is equal to 0. Count start from 0. Now I'm going to iterate to the array dot length I plus plus. Now here we will find the maximum max dot max of max comma array at I. The condition we need to increase our count was when the maximum is equal to the index, that is I. We have our count increased by 1, and at the end we need to return the count. So this is the simple code. So let's run this. Let's submit this. So code is successfully submitted, and we just need a maximum. We need a count to count the max chunks. We have just iterate from 0 till the length of the array. Find the maximum, and when the maximum is equal to I, this means we need to increase the number of counts of the chunk. Why we are increasing? Because if we sort them till this index 3 was the maximum. If we sort them, we will get the position of 3 at 3, the position of 2 at 2 index, position of 1 at 1 index, position of 0 at 0 index. This was the 0 index, 1 index, 2 index, 3 index. These were the values. If we sort them, this is the 4 index, 5 index. If we sort them, 5 is at the index 5 and 4 will be index at 4. Here this was 6, 7 and 8 index. 8 index, 8 will be at the 8, 7 will be at 7 and 6 will be at 6. Here we have the sorted array if we sort each chunks individually. So hope you understand the code and the solution. We will see you in the next video. Thank you.